आज इस वीडियो में हम खान यूनिवर्सिटी एग्जामिनेशन बोर्ड क्लास 11th सितंबर 2012 फिजिक्स पेपर 1 सॉल्व करेंगे। तो लेट्स कम टू आवर फर्स्ट क्वेश्चन इन दिस ईयर। So here we have our first question, question number 1 and question number 2. The units between the base and drive. The units between the base and drive units recommended by the System International are known as supplementary units. वो units जो कि base units और drive units में नहीं आते, but they are the part of our measurement, उन units को हम supplementary units कहते हैं। और supplementary units हमारे पास दो हैं for the measurement of two-dimensional angle, that is radian, and for the measurement of three-dimensional angle known as steradian. So option D is the right answer. Let's see question number 2. The diameter of the steel rod is 56.47 millimeters. So its true value cannot be less than which of the following? So 56.47 plus minus 0.02 millimeter means that its minimum value will be 56.47 minus 0.02, and its maximum value could be 56.47 plus 0.02. So this is the minimum value and this is the maximum value of that measurement. So 56.47 minus 0.02 will be equals to 56.45. So 56.45 is the minimum measurement, while 56.47 49 millimeters would be the maximum value of that diameter of that steel rod. So option A is the right answer. Let's come to our next question, that is question number 3 and 4. If two forces F1, F2, H on a body are balanced by the frictional force F3. So we have three forces. One is F1, F2, and the resultant is F3 because this force F is balanced by the other two forces. So and the body is in equilibrium position. So equilibrium position is the one in which the net force acting on the body is zero. This means that the sum of these three forces must be equal to zero. So from the head to tail rule diagram, how can we identify the equilibrium condition? The diagram should be such that all three vectors will form in a cycle, either in a clockwise or in a anti-clockwise direction. So F1 and F2 are added by head to tail rule in the option A, while F3 shows the resultant of F1 and F2. So this diagram shows F1 plus F2 and its resultant is F3. So net force is not equal to zero. Similarly, in this diagram, diagram does not show a complete cycle. The vector starts, the tail of the first vector should be the head of the last vector. So as we can see in the diagram D, the first vector starts at point A and ends at point B. Second vector starts at B and ends at C, and the third vector starts at C and ends at the initial position A. So इस डायग्राम के अंदर जहां फर्स्ट वेक्टर की टेल आ रही है वहीं पर लास्ट वेक्टर का हेड लाई कर रहा है. दिस मीन्स दैट इस वेक्टर डायग्राम के अंदर जो नेट फोर्स है वो जीरो है. बॉडी इज इन इक्विलिब्रियम. सो ऑप्शन डी इज द राइट आंसर इन दिस क्वेश्चन नंबर 3. Now let's see question number 4. If two forces of 3 newtons and 4 newtons are acting perpendicularly, and we have to find their resultant vector. So formula for the resultant vector is the square root of 3 square plus 4 square. That will make square root of 25 equals to 5 units or 5 newtons. So the correct answer is option B. Now let's see question number 5. Torque determines the body's angular velocity, momentum, acceleration, or displacement. So the correct answer is the angular acceleration. जिस तरह से जो लीनियर फोर्स होती है इट डिटरमाइंस द एक्सेलरेशन ऑफ द बॉडी. सिमिलरली सर्कुलर मोशन और रोटेटरी मोशन में जो टॉर्क है इट डिस्क्राइब्स द एंगुलर एक्सेलरेशन. जिस तरह फोर्स डायरेक्टली प्रोपोर्शनल होती है लीनियर एक्सेलरेशन के, सिमिलरली द टर्निंग इफेक्ट इज डायरेक्टली प्रोपोर्शनल टू द angular acceleration of the body. So option C is the right answer in question number 5. Let's move to our question number 6. So here we have our question number 6. Two balls are released simultaneously from a point A with the zero vertical velocity. So in both the balls, the initial vertical component of the velocity is 0. Similarly, in the second ball, initial component of vertical velocity is 0. The ball will reach the ground at the same time. दोनों balls, हालांकि first ball जो कि free fall motion possess करेगा और जो second ball है it will form a projectile motion, but still they will reach the ground at the same time. So अगर हम वर्टिकल मोशन को देखें तो वर्टिकल मोशन के अंदर जो वर्टिकल एक्सेलरेशन है इट इज इक्वल्स टू जी, वाइल दी हॉरिजॉन्टल एक्सेलरेशन इज 0 बिकॉज कोई हॉरिजॉन्टल मोशन नहीं होता. जबकि प्रोजेक्टाइल मोशन के अंदर अगर हम देखें तो वर्टिकल जो एक्सेलरेशन है इट इज ऑल्सो इक्वल्स टू जी, और जो हॉरिजॉन्टल एक्सेलरेशन है वो 0 होती है. तो दोनों के अंदर सेम कंडीशंस हैं, सेम चीजें हैं, बट वन इज फ्री फॉल एंड द अदर इज द प्रोजेक्टाइल मोशन. सो if both of these bodies are falling from the same height, this means that they will reach the ground in the same time. So option B is the right answer, that they have the same vertical height. Now we have question number 7. The following diagram shows the path of a projectile. At which of the following points does the projectile have the maximum speed? अगर हम projectile को throw करते हैं या move करते हैं, so किस point पे either 1, 2 and 3 the body will have the maximum speed. So as we know that body जब point 1 से point 2 की तरफ move करेगी तो horizontal velocity remains constant, जबकि जो vertical component है वो velocity का वो change होता रहता है. So ऊपर की तरफ move करते हुए velocity decrease होती रहेगी और दोबारा downward motion के अंदर velocity increase होती जाएगी. This means that at point 2 its vertical velocity is also equals to 0 meter per second. So the maximum velocity, maximum vertical velocity of the projectile will be at point 1 and 3. So option D will be the right answer. Let's see question number 8 and 9. In the given diagram, a man pushes a ball. The work done by the man will be 0. So this man is pushing the ball with a force F, while the work done is equals to force dot displacement. So force is there, but there is no displacement in the ball. The displacement is 0. That's why the work done will be equals to 0 joules. So the reason behind the 0 work is such that the displacement of the ball in the direction of force is 0. So option B is the right answer. In question number 9, we have a diagram in which force is acting with the displacement D and making an angle theta with the horizontal axis. So at which angle the work done is said to be negative? We know that work done is equals to FD cos theta, And for cos theta less than 0, the angle should be equals to 180 degrees. So cos of 180 degree is equals to -1. So in that case, the work done on the body will be is known as negative work. So option D is the right answer. Let's move to our question number 10. A windmill raises 500 kilogram of water from a well at a depth of 50 meters in 1 hour. What is the power generated by the mill? So this windmill is extracting the water and moving this 500 kilogram of water to a certain height. So in that case, work done is equals to the change in potential energy of the water. So for power, we know that power is the rate of doing work over time. Work is equals to potential energy, that is mgh, and the time is t. Mass of the water is 500 kilogram, gravitational acceleration is 10, height is 50, and the time is 3600 seconds. So this will be the expression for the power in watts. So let's see which of the following option matches with this expression for the power. 500 times 10 times 50 divided by 3600, or 16 to 60. Option D is the right answer. Let's see question number 11 and 12. Which of the following energy take place when a cyclist pedaling a cycle uses a dynamo to turn on his bicycle lamp? So here we have a dynamo, and this dynamo is used to pump on to light on the bicycle lamp. So the kinetic energy is involved in pedaling a cycle, and on the other hand, the output is equal to electrical energy or light energy. So kinetic energy is converting into electrical energy, and in a lamp, electrical energy converts into the light energy. So option C is the right answer. Then we have question number 12. A planet P moves around a star S in a circular orbit. The force which keeps it orbiting is due to the attraction or gravitational force between P and S. What will happen if the force suddenly disappear? So this force is towards the center of the this star S, and the direction of tangential velocity is tangent to the circular path. This is the direction of velocity. When this force suddenly disappear, this this planet P will move in the direction of velocity. So the planet P will falls towards S. P follows in orbits closer to the star. P goes off into space in a curved path, while P goes off in a space in a straight line. So this is the direction of velocity, or it will move in a straight line that tangent to the circular path. So option D is the right answer of this question number 12. Let's come to question number 13. A pendulum is set in motion in a horizontal plane. Which of the following diagram best represents the direction of resultant centripetal force? So if this pendulum is moving in a circular path, so we have to identify the direction of centripetal force. So the direction of centripetal force is always towards the center of circular path. Center of circular path. So the correct answer will be the option B, in which the resultant force is acting towards the circular center of the circular path. Let's see question number 14. The period of the geostationary satellite is, the geostationary satellites are the one that completes one rotation around the earth in 24 hours or 1 day. So time period of geostationary satellite is 24 hours, and 24 hours converted into seconds will be equal to 24 into 3600. So let's calculate this 24 into 3600, that is equals to 86,400 seconds. So this is the time period of our geostationary satellites. All of the following are the characteristics of describing the streamlined flow of fluid except for the one. So the fluids that are flowing in a streamline, that they should be incompressible, they should be non-viscous, and there should be irrotational flow. So this could be the condition for the streamlined flow in a fluid. Or option A, that shows that liquid should have unsteady flow, that do not describes, or that this is not the characteristic of fluid flowing in a streamline. So option A is the right answer. Let's see question number 16 and 17. In the given diagram, when a drag force and a gravitational force becomes equal, the drag force equals the gravitational force. This means that the upward and downward force are equal, and the net force or the resultant force would become equal to zero. When the force is zero, acceleration will be zero, and the body will fall with the constant velocity. And this constant velocity is known as our terminal velocity. So the correct answer for this question number 16 is option C, terminal velocity. All of the following are the examples of simple harmonic motion except for the one. We have to identify that which of the following motion does not describe or does not meets the condition of SHM. So the projection of body in a uniform circular motion, we have studied that the object moving in a circular path, its projection possess the simple harmonic motion on the diameter of the circular path. Swinging of a simple pendulum, mass attached to the spring, these are the motion that we have already studied in our course, that possess simple harmonic motion. Option A, the bouncing back of a ball from a wall or from a ground. So this is the motion this that does not meets all the characteristics of simple harmonic motion. Option A is our right answer. Now let's move to our question number 18. In the given figure, the motion of N on the diameter dE due to the motion of particle P in a circle, if the angle is between 270 and 360. So the 270 and 360 means that it is in the fourth quadrant. We have to identify the direction of motion of N. So if this particle P is moving in this fourth quadrant, and for this, the particle P or the projection of this particle P will be moving towards the mean position from extreme E to O. So right answer is option A. Let's move to our question number 19. Which of the following graph shows a relationship between the displacement D and displacement X and the acceleration A of a body executing simple harmonic motion? So at maximum displacement, let's say this is the maximum displacement. This is our maximum displacement. And at this point, we know that acceleration is equal to maximum. The acceleration is maximum while the displacement is also maximum. At this mean position, where amplitude or the displacement is zero, as so the acceleration is also zero. This shows that both these characteristics are zero at mean position while maximum at extreme position. Similarly, if this is the positive displacement, so acceleration will be positive, and for negative displacement, the acceleration would be negative. So let's see, here we have, this is the mean position, and at mean position, the acceleration is zero. And as we move towards the positive displacement, acceleration is also increasing, positive acceleration, and for negative displacement, the acceleration is negative. So this could be our right answer. In option A, at mean position, the displacement is zero, so the acceleration is zero. And when the body is moving from negative displacement to the mean position O, the acceleration is increasing. So in option A, and this is our option C. In these options, the positive displacement has the negative acceleration. Similarly, in this option C, the positive displacement has negative acceleration. So these two options are incorrect. So the correct answer is option B, in which positive displacement is positive acceleration and negative displacement has negative acceleration. And at mean position, the acceleration is zero, and at extreme positions, the acceleration is maximum. Let's move to our next question, number 20 and 21. If a pendulum makes 30 seconds to complete 20 vibration, we have to find its frequency, and it is equal to waves over time. Number of waves are 20 and the time for it is 30 seconds. So let's divide 20 by 30. It is equal to 0.666 hertz. So it will be equal to 0.7 hertz. If the frequency and the velocity of the sound are 30 hertz and 330 meter per second, we have to find the wavelength of the sound wave. So lambda is equals to V over F. Velocity is 330 meters per second, and the frequency is 30 hertz. So 330 divided by 30 will be equals to 11 meters. So the correct answer is option A. Then we have question number 22. All of the following produces sound waves except a cry in the air will produce a sound wave. A bell ringing underwater, an explosion in the outer space, and a gun fired in a room with no echoes. So option C is the right answer, because in outer space there is no medium, and a sound wave is a wave that require medium for its propagation. So there will be no sound wave in an explosion that occurs in the outer space. When a light bends around the obstacle, so this process is known as diffraction. The bending of waves from the sharp edges of an obstacle. So this bending or this spreading of wave is termed as diffraction of light. So let's see question number 24. If 5,000 lines are ruled on a diffraction grating of length 1 centimeter. So we have a length of 1 centimeter of a diffraction grating, and there are 5,000 lines ruled on that grating. Those slit spacing will be equals to, we have the formula, that is length over number of lines. So length is 1 centimeter. So option, we have all the centimeters. So we will not convert this into meter. 1 centimeter divided by 5,000 lines. So it will be equal to 2.0010 raised to the power minus 4 centimeters per line. So the correct answer is option B. Polarizer increases the contrast of a photograph because they can remove the reflection, refraction, diffraction, or polarization. So the correct answer for this question is option A, that the polarizer increases the contrast by decreasing the reflections from different objects during polarization. So let's come to our next question, that is question number 26. The value of Boltzmann constant, that is K, is equal to 1.38 exponent minus 23 joules per Kelvin. The temperature of the gas is 10 degrees and we have to find the average translational kinetic energy of the molecules. So the formula for the temperature and the average translational kinetic energy is T equals to 2 over 3K times mb square over 2. So this is the temperature in Kelvin, then this K is our Boltzmann constant, and mb square over 2 is the average translational kinetic energy. So for the kinetic energy, our formula would become T into 3K divided by 2. So this temperature in degree centigrade would become 283 Kelvin. So let's substitute the values. Temperature in Kelvin is 283 times 3 multiplied by a Boltzmann constant 1.38 10 raised to the power minus 23 and divided by 2. By solving this expression, we will get 5.86 10 raised to the power minus 21 joules. So the correct answer is option D. The absolute temperature of an ideal gas is directly proportional to which of the following? So as we have used this formula, this shows that 2 over 3K is a constant and the temperature is directly proportional to the average translational kinetic energy. So correct answer is option D. Let's move to our question number 28. If 5 kilojoules of work is done on the system, so the work done is on the system, and the type of work that is done on the system is termed as negative work, and 15 kilojoules of energy is given out by the system. So the energy given out by the system is termed as negative heat. We have to find the change in internal energy. So by using the first law of thermodynamics, that change heat absorbed or released by the system is equal to change in internal energy plus the work done by the system. So delta U will be equals to Q minus W. The value of Q we have is 15,000 joules, that is negative, and the work done is negative. It will be equals to 5,000 joules. So minus 15,000 plus 5,000 is the change in internal energy. So delta U is equal to minus 10,000 or 10 kg of energy. So the correct answer is option B. Then we have question number 29. Which of the following devices converts thermal energy into mechanical work? So that device is known as heat engine, that takes heat from the source and it converts into mechanical work or energy. So the correct answer is option D. Then we have the last question of this year, question number 30. So in this question, we have a PV diagram or for a gas, and we have to find the work done by the isobaric process. So if we recall the isobaric process in a thermodynamics, so isobar means at constant temperature, constant pressure. So let's identify the region in which the pressure of the gas is constant. So from X to Y, as we can see that this is the isochoric process because temperature volume of the gas is constant, and this is from X to Y, it is isochoric expansion. Similarly, X to Z, we have a change in volume as well as in pressure. So the region of the graph that shows the isobaric process is YZ. So we have to actually find the area under the curve of this PV diagram of the graph YZ. So the length of this rectangle is 6 minus 1, 5, 10 raised to the power minus 2. And the pressure is 1.1 10 raised to the power 5. The product of this will be PV is it will be equal to the work done. So the correct answer is 5.5 10 raised to the power 3 joules. That is equals to 5500 joules. So this is the work done of this isobaric process. So option D is the right answer.